Hello, my name is Ma'aris Nur Ashidi bin Manazir. My number matric is AE200016, and there I will explain activity 1, the series resistive inductive load circuits. According to the procedure, we have to create the circuit like the figure 8.11 and insert the 110 resistor and 0.4 Henry inductor, and the input supply is set to 10 volt and 50 hertz. So we open Proteus. So this is the circuit in our simulator. So as you can see here, the value is set according to the value given. So for the amplitude, we got 14.14 because we multiply the volt, the 10 volt with cert 2. So resistor, this is inductor. So we try run, and we got the value is 40.9 for current and 9.99 per 4 volt. So we got the value here, and then we do for others value. So after that, we compare the simulation value with the calculation value. So here our calculation, we find XL. After that, we can find the impedance, and then voltage is given, which is 10 volt. Using the Ohm's law, we can find the current. After we got the answer, we record it in the table. So that's all for activity 1. Thank you. Hi, for activity 2, the parallel resistive inductive load circuit. It is the same with activity 1, but the load is arranged in parallel. So it's the same. The resistance 210 ohms, and the inductor is 0.4 hertz. This is our circuits for the simulations, but we put the second resistor here because if we don't put it here, the simulation will show an error. So here, so after I do some research, it says that it have to be one resistor here, but we put the small value here, so it don't affect much. So I put 1 for the value. We can put 0.1 for the value, but the simulation will take too long. You can see it's so long. So it's okay, we put 1 as the value. So we run the simulation. So you can see here, we get for the current, we got 92.1 milliamps, and for the volt, we got 9.94 volts. So we record it in the table, the simulation value. So we do the same procedure using different loads, and we record the value in this table. So after that, we find the calculation value. So here, this is my calculations. So first we find XL, and then we find impedance using this formula because the circuit is in parallel. So the volt is 10 volt, and then using the Ohm's law, we find the current. So we record it in the table. So you can see the value is a little difference because we put the second resistor in the simulations. So but the difference is not too big. So the experiment is proof. So that's all for activity 2. Thank you.
Okay, for activity 3, we do the simulation for the series resistive capacitive load circuit, where we will insert 390 ohm resistor and 2 microfarad series with supply with 10 VAC in 50 Hz. And this is our circuit where this is the sine generator that will supply 10 volt and with 50 Hz frequency. And then we use the AC multimeter and AC voltmeter to measure the current and voltage respectively. And we measure, and here the reading and this reading for this circuit. And then after that we will change the value according to the table. And then we will compare the value with the calculation for voltage and current. For activity 4, we will do the parallel resistive capacitive load circuit, where the procedure also same with the activity 3, but now the resistor and capacitive in the parallel coordination. This is the circuit that we will use for the simulation, and this is the sine generator that apply 10 volt with 50 Hz frequency in the circuit. And now we will simulate. And here, this is the AC multimeter current shows the current flow, and this is the AC voltmeter that show the volt value for the circuit. After that, we change our value according to the table and compare with the calculated and simulated value. That's all. Thank you.
For the activity 8, the question asks to do the simulation for this circuit, and they give for input supply is 50 VAC and 50 Hertz, and the value for R, L, and C they give this table to we do the simulation to get the value and I total. So we open our simulation. Okay, I already key in the value here, and for the value here is 50, and we run the circuit. This what we get for ammeter and for the voltmeter.